All right, so we started talking about correlation versus causation yesterday, and that there is a difference between the two, that you can have a correlation or a relationship, but that does not imply that one automatically causes the other. All right, below is a scatter plot of data from the city of Copenhagen for the 10 to 12 years following World War II. The graph records the annual number of storks nesting in the city and the annual number of human babies born in the city. So if we look at our x-axis here, that's where the storks are. The y-axis is the babies. So the first question they're asking us here is, what is the independent variable in the relationship and what are its units? So looking at those, and we haven't talked about independent and dependent variables for a little bit, but which variable is usually the independent variable? Gabriel? The what? We don't have years on the graph. What are the two labels on the graph? Storks and babies. So between storks and babies, which one of those, based on their position on the graph, would be the independent variable? The storks. The x variable is usually the independent variable, because remember, when we graph the x variable first, so the y variable depends on where we had graphed that x. So, and we're going to work on writing answers in complete sentences, because writing in math is something that we should do. It shouldn't just be yes, no. So we're going to make sure our answers. So the independent variable in the relationship is storks. And what are its units? Well, the units are the number of storks nesting in the city, the annual number of storks. The units are the annual number of storks nesting in the city. So if storks is the independent variable, what is the dependent variable in the relationship? Baby. So the dependent variable in the relationship is babies. And the units here are the annual number of human babies born in the city. All right, the third question says, describe the trend and the strength of the relationship. So if I go back to this graph, what is the trend and the strength? By the strength, is it positive, negative, if we're saying there's a trend? So is there a trend here? Can we say, we're looking at, do both variables increase? Does one variable increase, one variable decrease, or no relationship? That's what we're looking at here. What is happening? Both variables are increasing. So Camilla, what would that be? If both variables are increasing, what kind of correlation is that? Positive correlation. So there is a positive correlation in the relationship as the number of storks increases. The number of babies increases. All right, the next question says, write a sentence that explains the claim in the scatter plot. Based on that graph, what are they trying to claim? We'll talk about whether there actually is causation or not in a minute, but what is the claim that they are trying to make with this graph? And again, we'll talk about whether the claim is true, but what again, the claim is usually that the independent variable is causing the dependent variable. So in this case, what would that claim be based on our variables? Yes, Lila. It's actually flipped around because remember, storks is our independent variable. So actually the claim in the scatter plot is that the increase in the number of storks is causing the increase in the number of babies. So the claim in the scatter plot is that the increase in the number of storks is causing and the increase in the number of babies. And I hate to be the one to burst your bubble if you didn't know that storks do not really deliver babies. Sorry if that is news to anybody, that storks don't really deliver babies, and that's just a fairy tale that is used. Stork is the bird. I don't have a picture, but a lot of times in, especially in children's books, it'll be the big white bird flying with holding the baby in a blanket. Storks are real birds. Obviously, babies are real. When you're little, we do imply that one brings the other. I would hope by now you know that that is not how babies make their way into the world. But that's as much as I'm going to say on that situation. But that's, if we just look at the graph, that is what the graph is implying, is that one is causing the other. So again, they say correlation does not imply causation, is a phrase used in statistics to emphasize that a correlation between two variables does not imply that one causes the other. So does the scatter plot support correlation or causation? Well, we've already said it supports correlation. But do storks really cause babies to be born, human babies to be born? No. So the scatter plot supports correlation. Not causation. And it asks, is causation reasonable? And it's not, because storks do not deliver babies. So causation is not reasonable. Storks do not deliver babies. Now, the thing is, can you think of a third variable that would explain the correlation between number of storks and number of babies born? This is where I'm going to give you a minute. Go back and read what's at the top of the graph. When did they gather this information? And I want you to talk about it in your groups. Is there a third variable that could be causing both of these? So I'm going to give you a moment to talk about it. All right, so what do we think could be a possible third variable that could explain why both of those things are increasing? When was this data gathered? The 10 to 12 years after World War II. So I realize it's been a little bit of time since World War II, but what, you guys study history, what do you think happens after a war? Lila? Well, people died in the war. In the war, there was a great loss of life in the war. Camilla? people come back from the war. And do you think the same thing happens to animals? Do you think animals evacuate an area that's not safe? Yeah, so that third variable that is probably causing this is the people and the animals are returning to where they belong after the war. So the third variable could be with the end of the war, people and animals were back where they belonged. So that is more likely to be the cause of both of those increasing than storks causing the number of storks increasing, causing the number of babies to increase. They are both increasing because the war has ended and now people and animals are returning to where they feel safe or where they belong. All right, we have another graph on the next page, another situation here. All right, so here's our graph. Our x-axis is consumption of ice cream. Our y-axis is drowning deaths. Write a sentence that explains the claim in the scatter plot. Pay special attention to the x-axis values. So what are they claiming? Not saying what's true. What are they claiming in this graph? Yeah, they're claiming that consuming ice cream is causing drowning deaths. That's what the claim is. Again, not to say if the claim is true. So the claim in the scatter plot is that the consumption of ice cream causes drowning deaths. Because again, the x-axis is usually our independent variable and the y-axis is our dependent variable. Now the next question asks, is it reasonable to say that ice cream consumption and number of drowning deaths are correlated? Again, not causation, but correlation. If I go back to this graph, is there a correlation, either positive or negative, in this graph? Camilla? They're both increasing, which is showing us a positive correlation. So is it reasonable to say that they are correlated? Absolutely. It is reasonable to say ice cream consumption and number of drownings have a positive correlation. What variable is dependent on the other? And the number of drownings depends on the consumption of ice cream. Is causation reasonable? Does eating ice cream cause more people to drown? So causation is not reasonable. Can you think of a third variable that would explain the correlation? And I'm going to pause for a moment while you talk this over in your groups. If ice cream consumption isn't causing the drowning, what is causing both of them to increase? I'll give you a moment to talk that over. All right, so can we think of a third variable that would explain the correlation? If ice cream consumption isn't the cause of the drowning deaths, what is causing both ice cream consumption to increase and drowning deaths to increase? Camilla? How hot it is. Weather usually influences both of those. When the weather's hotter or warmer, we consume more ice cream. When it's warmer, we also swim more, which would lead to drowning deaths. So a third variable could be hot weather. Which causes both to increase. So again, a scatter plot can show us a relationship, but we have to be cautious that it doesn't mean that one causes the other. There could be a third variable in the works that is causing both. All right, the next page, now we're going to get to actually do a little bit of graphing, do a little bit of work here, which this really is kind of why I wanted to get into this activity, to talk about this, get a little hands-on with this. So the height and scores on a math test are shown for students at Clare Elementary School. Make a scatter plot of the relationship. So And we're going to change question 5. I don't worry about, we haven't talked about the line of regression and the correlation coefficient. We're not going to get that deep into it, but we can still do our own data and graph here. Now, the top line is the height in inches, so I'm going to write my label off to the right because I want to leave room to write the numbers. So our x-axis is going to be height, and again, it's in inches, so I put inches in parentheses. And then my y-axis is going to be the score as a percentage. Now, the lowest height is 40 inches and the lowest score is 45%. We talked about this. I don't want to have to do a graph that covers all of those. There's a portion of the graph we're not using, so that we don't have to use the entire graph, because the graph does have to start at 0. Okay, where those two axes meet, it does start at 0. But remember, we talked about we can show where we're not going to use the whole graph. I can kind of do a little break there to show I'm not using the whole graph. And I'm going to try to do the same thing on the other side, though they're going to kind of run into each other, because I don't want to start from 0. The data doesn't start close to 0, so I want to be able to work with that. So if my lowest one is 40, and I only need to go up to, I think my biggest height is 60, I can actually count by 1, so I can label 40, and then I, just so the numbers aren't too close, I'm just going to write every other one. Again, just giving it room to space out. And again, my lowest test score is 45%. My highest is 94%. Unfortunately, there I don't have enough space to even count by 2s. So I'm going to have to go by 5s on my, even with being able to skip part of the graph. So we're going to start 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. So even with skipping, I can't even count by 2s because there's a broader range of test scores than there was a range of height. So anytime you're going to do any type of graph in a real world situation, you need to label your axes, and then you need to scale your graph appropriately based on the data you have. Now, once we have our graph set up, the next thing would be to actually just go into the ordered pairs. So my first ordered pair, the height is 42 and the score is 50. So I go to 42 on my x-axis, up to 50 on my y-axis, and there's my first point. I'm just taking the numbers from that table at the top of the graph and graphing the ordered pairs. Then we have 40, 45, 46, 62, 48, 65, 52, 70, 54, 70, 56, 70, 57.75, 53.74, 54.80, 57.85, 57.84, 58.88, 59.92, 60.90, and 60.94. Again, that is simply taking the data from the table and graphing those points as a scatter plot. All right, so we need a line of best fit. Now, there is some math that can be done, and again, we're not going to get into the math of it. We're just going to try and put in a line that comes closest to the data. So I'm going to take my straight edge. Now I do need points on the line to make this happen. So I do need to make sure that I have that this line goes through 2 grid points. And it looks like I can use one of those points as 60/90. And I think I'm going to be able to do 52/70. So I'm going to use those as my 2 points to draw my line. Ooh, that one went a little high, huh? Okay, try that. Again, we don't want all the extra points to be above or below. This line should kind of go through so that there's a mix of points. Through our data. So it looks like I can use the point 59.90. And then another point looks like I can use 46.55. And again, the reason we need 2 points because we've got to be able to do slope and we've got to be able to do y-intercept. What is the equation of that line? Reminding you again that slope is y2 minus y1 divided by x2 minus x1. So in this case, our slope is going to be 90 minus 55 divided by 59 minus 46. So 35 over 13. And since 13 is a prime number, we can't simplify that any further. And then I'm going to use my 59 and my 90 as my x and my y to find my y-intercept. So 90 equals, well, this is going to be some ugly math, 35 over 13 times 59 over 1 plus b. I'm going to help you out with this math because this isn't going to be the prettiest of equations here. So 35 over 13 times 59. Oh, this is really pretty. So we have 90 equals 2065 over 13 plus b. Then we have to subtract that. So we have to do 90 minus that. And that gives us a negative 895 over 13 equals b. Now again, just because the numbers aren't pretty, it goes to show that every line does not have a 3x plus 2 equation to it. So we found our slope up here. We found our y-intercept. And again, it's just to write that equation, we're taking those two pieces of information and putting it into our slope-intercept form. So y equals 35 over 13x minus 895 over 13. All right, so we've written the equation of the line that goes with that line of best fit. Again, we aren't doing the line of regression or the R value. That is something we're not going to get into this year. But again, wanted to practice writing that line because it does come up in one of the Alex assignments where they give you a scatter plot with a line of best fit. And then they ask you, they show you where there's 2 points on the line and you have to use those 2 points to get the slope and the y-intercept to write the equation of that line. So we've done all that part, and now it's asking us to describe the relationship shown on the scatter plot. Well, the relationship shown implies that as height increases, test scores increase. And does that make sense? Do we think that someone's height is causing them to have better test scores? And I believe we talked about earlier that there is a possible third variable, which we will get back to. So it does not make sense that an increase in height causes an increase in test scores. And we're going to get to a question in a little bit where it's going to ask us, what do we think could be an independent variable that would cause that dependent variable of test scores? So we'll get to that in a moment. So that sums up that third one. On the next page, they're just going to, it's kind of like a recap page of the three situations that we have looked at. The first one, if you recall, was the storks and the number of babies born. The next one was the ice cream sales and the number of drownings. And then this one, which was the height and the test scores. All right, so on the next page, it asks us, is the independent variable in the three relationships a causal factor of the dependent variable? Explain your reasoning. Well, the number of storks is not a causal factor in the number of babies born. A third variable of the war ending most likely caused the increase in both variables. So again, correlation does not imply causation. We're seeing this here where we have some variables that had a relationship. They were both increasing. It was a positive correlation, but one did not cause the other to occur. Again, the second one was ice cream sales and the number of drownings. And we again said the ice cream sales are not a causal factor in the number of drownings. A third variable of hot weather most likely caused the increase in both variables. So again, there is correlation, there is a relationship but it does not mean that one is causing the other just because we have a relationship. And then the last one we just looked at, the height and the math scores. Height is not a causal factor in the increase of math scores. Now, the next question is actually going to ask us what we think that variable could be changed to. So here I'm just going to say there is a third variable that is most likely causing the increase in both variables. So on that third scenario, the height and the math scores, the height was the independent variable. But what could we change the independent variable to that could be a causal factor of the test scores going up? What do we think could be causing both height and test scores to be increasing at the elementary school level? What possible third variable could cause both of those to increase? Do we think a kindergartner would score the same as a third grader on a math test? So what would cause that kindergartner to both grow in height and increase in math score? So the age of the child as the independent variable could be a causal factor of math scores increasing. As you said, you learn more. Well, why do you learn more? Because you are getting older. As you get older, we teach you more, so you know more. So age could be a causal factor. And then the last question, what is the difference between correlation and causation? Correlation indicates that two variables are related in either a positive or negative way. Causation means that the change in one variable directly causes the change in the other variable. So correlation just means they're either both moving in the same direction at the same time or opposite directions at the same time. Causation means one of them is actually causing the other to change. There's a direct relationship there.